Okay, so we have this warm-up here, and it'd be best if you paused the video and did the warm-up on your own. When you're finished with the warm-up, you can unpause the video, and I will go through the solution together. So pause the video now. All right, so hopefully, as you went through this warm-up, we have 3 coins. They're tossed. How many different outcomes are there? Okay, well, the first coin could have been heads or tails. The second one could be heads or tails. And the third one could be heads or tails. So we have 2 outcomes for the first toss. We have 2 outcomes for the second toss. We have 2 outcomes for the third toss, and that makes 8 outcomes. If we list the sample space, so the sample space are all the possible ways this could have happened. So it could have been that we got heads, heads, heads. We could have gotten heads, heads, tails, excuse me. We could have gotten heads, tails, heads. We could have gotten tails, heads, tails. We could have gotten tails, tails, tails. We could have gotten tails, tails, heads. We could have gotten heads or tails, heads, tails, and we could have gotten heads, tails. No, your head, heads, tails, heads. We could have gotten heads, tails, tails. So these are all the different ways that we could have flipped 3 coins, or flipped a coin 3 times, however you want to think about it. And this is the sample space right here. I don't think I left any out, right? And so, going through this next one, in a standard deck of cards, how many cards are aces? Well, in a standard deck of cards, there are 4 aces. How many of those are hearts? Well, there's 1 suit of hearts, and there's 13 cards that are in a suit. 13 times 4 gives you your 52 cards in a deck of cards. And so there are 4 aces, and there are 13 hearts. That's really leading us into our first question here, which is, what is the probability of drawing an ace or a heart? Okay, so I'm happy if I get an ace, and I'm happy if I get a heart. Okay, so we just said how many cards are aces? Well, there's 4 cards that are aces out of the 52. Okay. Actually, in general, I just know that there's going to be 52 cards that I could pick. So that's going to be the total sample solution set here is I could pick any of the 52 cards. 4 of them would make me happy. Plus the 13 hearts, that would also make me happy. Because if I got an ace or I got a heart, then I'm happy. But the problem here is there is a card called the Ace of Hearts. And the Ace of Hearts I counted here because it's an ace, and I counted it here because it's a heart. So that means I counted the Ace of Hearts twice. So I want to subtract out one of those so that I've only counted it 1 time. And so I'm subtracting out the 1 card that is both an ace and a heart. I'm subtracting out the Ace of Hearts. And so 14 plus 13 is 17, but that's if I count the Ace of Hearts twice, once as an ace and once as a heart. And so there's really 16 cards out of the 52 that I would want. And so that would make me happy, and so that's what the probability is. And we can reduce this. We could divide by 2. That gives us 8 out of 26. We could divide by 2 again. That gives us 4 out of 13. And at that point, This is as simplified as it gets. I can also write this as a proportion, so that's 0.308, or I could write it as a percent, that's 30.8%. So all of these would be valid answers for a probability. So let's move on to the next problem. Remember, you can always pause and re-watch these videos to get a sense of what's going on. Okay? So let's talk about what happened there. This is called the addition rule. Okay? So the addition rule says that if we are finding the probability of P or a probability of A or B happening, so I don't care if it's one or the other, both would make me happy. If both of them happen, that also makes me happy. So to find the probability of A happening or B happening, we add the two probabilities together, and then we subtract out any that have repeated. So we subtract out any place where A and B are happening at the same time. So on that last example, we counted up all the aces, we counted up all the hearts, and then we subtracted out anything that was both an ace and a heart, which is the one card, the ace of hearts. So here's another example. 43% of the world's population have type O blood, 85% of the world's population are Rh positive, and 37% have type O blood and are Rh positive. What's the probability that any individual will have type O blood or be Rh positive? So we're looking for the probability that somebody has type O blood or are Rh positive. Okay, so that's going to be the probability that someone has type O blood plus the probability that someone is Rh positive. But if I counted all the type O people here and all the Rh positive people here, then I counted some of the people that are Rh positive as well here, and I counted some of the people that are type O positive, or type O blood here as well. So I need to subtract out those duplicates. So I'm going to subtract out the probability that somebody has both O and are Rh positive. So I need to subtract that out. So let's go ahead and do this. I know the probability that somebody has type O blood is 0.43. I know that the probability that somebody is Rh positive is 0.85. And I know that 37% of people are both. And so I counted that 37% already in the 43% that have type O and the 85% that are Rh positive. And so I'm going to subtract out 0.37 and 0.43 plus 0.85 minus 0.37 is 0.91. So we get 0.91, or we could write that as 91%. Okay? It's important here, the big giveaway is, if I didn't remember to subtract out the duplicates, I would end up with a probability of 128%. And remember that, or 1.28. Remember that probabilities, when they're proportions, have to be between 0 and 1. And when they are percents, they need to be between 0 and 100. So getting something over 100% doesn't make sense, and that will be the warning that you forgot to subtract out the duplicates. So 91% is the correct answer here.